welcome to Military and Aerospace Electronics Tech Summit Quick Chat with software specialist AdaCore in New York City. I'm John Keller, Chief Editor of Military and Aerospace Electronics. Today's presenter is Tucker Taft, Vice President and Director of Language Research at AdaCore. Tucker, I understand you'd like to introduce the QGen Auto Code Generator for Simulink and Stateflow and explain the advantages provided by a TQL-1 Qualification. Could you tell us a little bit about that?
Sure. Well, let's start with some vocabulary. QGen is an auto code generator, sometimes just called a code generator. And what that means, it takes in generally a model written in some modeling system and produces a program written in some programming language. So it used to be something that was done by teams of programmers. They'd say, oh, here's the model. It does just what we want. Now go write the program. But more recently, there have been these auto code generators. And in QGen's case, the input is a Simulink or Stateflow model. And the output is the safety-oriented subset of C called MISRA-C, or the formally verifiable subset of Ada called Spark. And as I said, it wasn't uncommon for programmers to have to do this by hand, but now you can imagine if you can just push a button and boom, generate all the source code, that's a little bit more efficient. In fact, one reason we got into the business was that we sell compilers for programmers, and we had a customer who stopped using our compiler. They said, well, what's going on? I said, well, we just generate all the source code using this tool. And I said, oh, we better find out about that tool. Anyway, so that's been a great innovation. But one of the issues is that, at least in the past, people like the FAA, who are certifying the safety of software-intensive systems, were not completely convinced that they should trust the output of a code generator. And so they would sometimes require the user of such a code generator to basically retest the output as though it were written by hand. And you can imagine that was a little disappointing, having gotten this magic output to have to then pretend like you wrote it by hand. So the next step really was to how do you build the trust in such a code generator? And that's where the term TQL-1 comes in. That's a level of trust. It's the highest level of trust that the FAA recognizes. Generally, the Q there is for qualification. If you're going to be using a tool in a safety certified system, then the FAA and other agencies require you to qualify that tool to prove that it really does the job and it accomplishes the kind of, it meets the requirements of your project. And so qualification is something that people, and certainly military and aerospace business, understand as something that tools have to do.
Right.
The DO-178C standard defines various levels. I mentioned TQL-1 is the top. TQL-5 is one of the lower levels, and that's used for just kind of verifying. It doesn't create any code, it just verifies existing code. But you can imagine if you're going to be generating the code, then that tool might be inserting errors directly into your program. Whereas a TQL-5 kind of thing, well, the program was written by humans, they were very careful, and it's just helping you find if there might be some bugs. But if the tool itself is generating code, then clearly you have to work a little harder to convince the FAA. So if you can get the TQL-1 level of trust, and it's a lot of hoops to jump through to do so, then the user doesn't have to review the generated source code by hand anymore. And that's a great savings.
Now, does this relate at all to, when the FAA and other authorities are looking at certifying avionics, and I usually think of computer hardware when I talk about this, but the DAL-A, DAL-B, DAL-C, is there any relationship there?
There is, absolutely. I mean, DAL-A is the highest level of certification for the software that's actually flying. And if you're going to be affecting the safety of that kind of software, then you need the highest level of qualification for the tools. So there is sort of a correlation, DAL-A, TQL-1, maybe lower levels of DAL, you might be able to use tools that are somewhat lower level.
Right, okay. Are there other TQL-1 qualifiable auto code generators for Simulink and Stateflow And if not, why not?
QGen is the first for Simulink. There are similar tools for other modeling systems, but Simulink is really dominant in the industry these days. And so we decided to focus on Simulink. And there are other tools for doing verification of code generators for Simulink, but they tend to work after the fact. They basically say, okay, well, we'll go ahead and generate the source code. Then we'll try to verify that the source code is in some sense equivalent or safe and so on. But our customers have found that knowing that the code comes out correct just simplifies their whole certification process. They don't have to do this extra step afterwards. And it turns out that sometimes that extra step may complain when it shouldn't and so on. So the whole process is sort of more robust and efficient from their point of view. But you do ask, well, why isn't there another one? And the reason is this is a huge amount of work to do this TQL-1 qualification. It's one of those things, like most software say, well, if you actually knew how expensive it was before you started, you probably wouldn't do it.
Sure.
But we're still going to finish this, but it is one of those things where it's a huge job, and we're the first to do it for Simulink. And one of the challenges with a system as rich and evolving as Simulink is that you've got to specify very specifically what you're going to do. So pretty early on, we identified a pretty large subset, which we consider the safe subset, which is the kind, basically talking with military and aerospace folks, what part of Simulink do you feel comfortable using in your flight software? And with that information, we were able to focus on that part of the language, specify that part of the language really well. And it's like 120 blocks, so it's a lot of features, but still it's not the full language. It's not changing as quickly. So once we specify the part that we're going to actually support, that makes our life a little easier. And so we go through a process that's very similar to what DAL-A level software has to go through to define the requirements extremely rigorously. And we have to do a very large test suite to prove that we actually met our requirements. And so that's the real reason, because you have to be a little bit crazy to do this.
Right. All right. Well, what sorts of customers are you targeting with the TQL-1 Qualifiable QGen Auto Code Generator? Are you looking at customers in government, prime systems integrators, subcontractors, embedded computing suppliers? Who's really the sweet spot there?
Yeah, well, military and aerospace is really where we focused initially, but other industries who are building software that when it breaks, people might die. Safety critical software have always been AdaCore's focus, and it continues to be our focus here. And there are obviously people who care a lot about this, and they're the ones who typically have to go through a certification with some agency like the FAA, or for high-speed rail, there's a separate agency and so on. So those sorts of industries, medical devices is an area where things are getting really complicated, and you've got a insulin pump or something that you control from your iPhone. It's like, well, I don't want that to be, insecure.
Right.
So that's the focus for us, and in particular, military and aerospace. One of the challenges for these people trying to use qualified tools is that typically it has forced them to freeze on a particular version of their tools. And some of these projects last a long time, so they end up frozen on what might ultimately be a very old version of the tools. So when we entered this market, we felt we wanted to try to address that issue. And in the past, we have used a subscription model for the source code or for the tools that we sell, compilers and so on. You get an annual fee, but with that fee, you get full support, very high-end support, and you get full upgrades and so on. And so we wanted to see if we could bring that same model to the qualification world. And it's sort of innovative. I think we're shaking things up a little. And it's still early days, but we are getting a lot of interest in that approach. So the customer now is getting a qualification kit that every year we will upgrade it according to their requirements. So it could be just a new version of Simulink. It could be some new features. There could be other things that we do every year. So you don't get stuck in this frozen, we can't afford to get a new qualification kit because it costs us to, basically just buy it again. So instead, we've approached it with this subscription model in mind. The other thing that is a lot of our customers, especially in military and aerospace, are large enterprises, and they don't want to buy the same thing 6 times because they have 6 projects that really are fundamentally doing the same thing. So we have introduced an enterprise-wide qualification model. So you can use this qualification kit for all of your projects that have the same basic requirements. And in the past, what's happened is that one project has bought one qualification kit this year. 3 years later, someone else buys one. They freeze on different versions of the tools, so that makes things harder and so on. By making it enterprise-wide and providing an annual subscription, we help big customers avoid that sort of problem.
Okay, so within military and aerospace applications, are you really speaking to embedded computing type of software programmers? Are you looking up in the Northrops, Raytheons, BAE Systems of the world, or are you looking to sell into government? Where's really the
government often doesn't have to certify its own stuff, which that's not completely true, but I'm sure they go through the same level. But we're focused on the big companies. Rockwell Collins has been a partner of ours from the very beginning on this process, but also we've been working on this for a decade or more and have been working with companies in a lot of different industries, recognizing what are their real requirements, what are their real pain points. And Rockwell has turned out to be a sort of an ideal first, big customer. They have a lot of different projects. Many of them have to go through some kind of certification. And they've been with us now long enough that they're already beginning to get to the point where they need to certify some of these systems. And so they're going to be probably our first user of the fully qualified version of TQL-1.
Okay, well, that kind of leads me into the next question, which is, do you have any initial users of the TQL-1 qualifiable version of QGen? I assume that Collins Aerospace is probably among your early adopters. Anybody else?
I don't have other names I can give you, but I can tell you what industries we're talking about. We have a medical device company that is very interestingly building a system that has been adopted for use with COVID-19. It's an oxygenator for blood. And you can imagine you want to get that right.
Right.
And they also have certification requirements, very serious ones. We also have a company that's looking into doing drones or maybe even, kind of taxis, maybe there's no driver, but there's that are flying, wow, who knows? So there's still the big companies are the aerospace companies, but there's some other smaller ones which are kind of interesting and also have these same certification requirements.
Okay. Is QGen just a code generator, or does it come with any other tools?
One real advantage we have in entering this market is we're coming from the bottom. A lot of companies sort of come from the modeling end and say, oh, we better build a code generator. We say, we've got compilers. We better build a code generator to keep feeding those compilers. And with that knowledge, we've been able to incorporate a lot of lower level tools that are really what you need when you get to testing on the final target. So things like testing and coverage tools, static analysis tools, formal verification tools. And probably our most interesting tool is a debugger. It's a model level debugger, but it actually can debug code that's running in a target machine. And with that debugger, you can show your model in one pane. You can show your source code that's been generated in another pane. You can even show the assembly code if you want, and you can be connecting directly to the target. Also, in a lot of these systems, there's a fair amount of handwritten code. It varies. Some they can do it all with the model, but other times there's a lot of lower level code. The debugger, because it's coming from below in some sense, it already knows how to debug Ada and C code very well. So you can go from some model-oriented code, and then you can drop into some low-level code. And the debugger can follow right in there. You can set breakpoints, look at values, and so on. So it is a really nice, complete set. And it's not coming from third parties. It's all something that AdaCore has full knowledge of and can give you really good support for. So it's kind of a nice combo.
Okay, we've got about a minute left. What's the roadmap for QGen and its enterprise qualification package?
Well, certainly we're starting with FAA as the certification agency we're worrying about. Then there's EASA, which is the European one. There's a Canadian one, and so on. So there are a bunch of different agencies which sometimes have their own special ways of looking at the world, if you will. But also, we're really driven by our customers at AdaCore. So the more customers we have, the more ideas they will give us about, if you could just add this, this would make our life easier, or add this new tool. Fuzzing is an area that's become quite hot recently. We've been investing in fuzzing technology, so we anticipate that as well as other things. But the big focus is streamlining the certification process. Anything we can do to make it less painful to certify a large system.
Okay. Well, thank you again, Tucker, for your time today. Just a reminder that today's session will be available here within the Military and Aerospace Electronics Tech Summit platform for the next 30 days. So on behalf of Military and Aerospace Electronics Tech Summit and our sponsor, AdaCore, we would like to thank you for joining us today.